American, been here for 25 years, worked in, started my career in the Navy, then I got a business degree and did a little bit of Wall Street before jumping into Northrop Grumman. So I have a little bit of a composite background, actually. They're scaled composites that the company owns. And then in 2015, I jumped out and got back into startups. So I've been in kind of the deep tech, startup, new emerging technology space since then. And really my honor to kind of talk to all of you gentlemen who are really forging the future. We're going to talk about composites, new types of materials, new types of aircraft, and learn about where we're going in the next decade or so. So with that, I'm going to turn it over to Lexi to introduce yourself, your organization, what you're doing.
Hello, my name is Alexei. I'm the CEO of Nautilus. We are a 7-year-old startup in the growth phase right now here in San Diego. We've been under the radar, but we have a $24 billion order book. We design, build, and sell airplanes, so very new to San Diego.
Hi, my name is Tam Nguyen. I'm founder and CEO of Alpha Precisions. My background started 20 years ago from manufacturing as hands-on machinist, mechanical engineer, and I founded the company Alpha 13 years ago. Been bootstrapping, started out as traditional machine shop, doing high precision manufacturing parts for defense and aerospace. And we kind of evolved since then, started to do more advanced manufacturing in terms of utilizing robotic system and AI software to streamline more processes and build parts faster. So that's a goal that we're trying to achieve right now. Thank you.
Hey everyone, Cooper Keller. I'm the Senior Vice President of Divergent Technologies. Divergent is a manufacturing technology company up in Los Angeles. We're about 400 people. Series E raised about $750 million to date, founded in 2014. But what we've built is really the world's first and only instance of a truly digital and adaptable production system. So by that I mean we've built an entire software and hardware stack that allows you to go from vehicle requirements to a entire safety critical structure for that vehicle, whether it's automotive or aerospace, in a matter of weeks. I mean, you're generating the design in hours and you're manufacturing it in days and weeks, compared to months and years with traditional manufacturing. So we deployed our system widely across automotive. We're working with Bugatti and McLaren and Aston Martin and a number of other OEMs that I'm not privileged to talk about. And Saab, although not automotive anymore. And then, yeah, now since about 2022, have focused a lot of our attention on defense products.
And Michael.
Thank you, Ellen. Very happy to be here. I'm also local. My name is Michael Brasser. I'm the Chief Strategy Officer of Saab Inc., which is the U.S. subsidiary of the Swedish defense company Saab. You may think we make cars. We don't make cars anymore, although we know the Saab owners love their cars, but that's what happens when a jet company makes a car. So like I said, the Chief Strategy Officer for Saab Inc., which is the U.S. subsidiary of Saab AB, about 1,000 people, a whole range of offerings from radars, jets, autonomous underwater vehicles, and shoulder-launched weapons. And we just launched a new effort here in San Diego called Scapa. Scapa is Swedish for to create. And I lead this effort. I'm the GM for Scapa by Saab. And the main focus here is robotics and artificial intelligence. So looking forward to talking about that. I just finished a 26-year career in the Navy, during which I passed through San Diego and said, I want to come back to this place. So very, very happy to be here today.
Glad you are here. So Lexi, I'm going to go back to you since your intro's short. So what are you building and why is it called Forging the Future? How do you play a role there?
So Nautilus is focused on building a next generation Boeing aircraft. So we actually compete directly with Boeing and Airbus, which is very ambitious, I must admit. But our investors are really excited about it, especially with the shortfalls in the industry. We feel that, along with our investors, that competition breeds better products. And so Boeing has had literally zero competition over the last 20 years. And so we are prepared to actually go up against it. In fact, laughing joke, but senior Boeing management still don't believe that Elon Musk actually went to space. So, I think there's very much an opportunity to really drive into it. Our first suite of products is actually destined around passenger airplanes. Beachhead is cargo, but the second one is going after the 737 market. To give you a perspective, the 737 was built for $1.1 billion in 1967. Those engineers did not have calculators or CAD computers. And so the next project is projected to be $50 billion. So Nautilus is there to disrupt that space and to make sure that we don't build an airplane for $50 billion.
Pull on that thread, how are you disrupting it? Is it just you're going to reduce that cost, I imagine, and using AI? I don't know, natural language processing. What are we doing?
We're way more simplistic than that. So we design and build something called a blended wing body. It's an airplane that looks like a flying wing, meant for passenger travel. So imagine more like space for the first time ever. That's a really big plus for me, being 6'4". But it's a suite of passenger and cargo airplane. We design, manufacture, and sell those airplanes to major airlines all across the world. We currently have a $14 billion order, which is not announced yet, to one of the major airlines here in the United States.
Very good. I'll pull on a kind of a similar thread. So going back to you, Michael, you're building Scapa here. You want to do robotics and AI. Like, how are you thinking about it? Is it in San Diego, or is it just covering all of United States? I mean, how are you thinking about Saab's entry here?
Yeah, so thanks, Ellen. We chose San Diego for a very specific reason. Well, let me just sort of backtrack a little bit. As I finished out my career in the Navy, I led this robotics and AI task force called Task Force 59. Was based in the Middle East, focused on securing the waters around the Arabian Peninsula and leveraging dual-use commercial technologies in that space, robotics above, on, and below the water. And during that time, I saw a huge capability acceleration by getting the products in the hands of the end users versus real problems in a very unforgiving environment. And so that notion of rapid iteration alongside the end user was very, very important. And I saw the capability accelerate very, very quickly. So when we were creating Scapa, we wanted to be very, very close to the end users. In San Diego, you have Naval Special Warfare, you have the Pacific Fleet, you have Third Fleet, NIWC Pacific, I could go on and on. And so we planted here, but that's just to accelerate the capability, to get that rapid iteration, that tight iteration cycle to accelerate what we're building. But we're looking globally in terms of the market.
So if I were to then pull the thread, since you're focused on robotics and stuff, how do you see leveraging those technologies with, I guess, I don't know what kinds of systems you're building? And then, since you're selling to our DoD, how is that going?
So it's going very well. The robotic space is very crowded and getting more crowded by the day. We've really found a exciting niche in the AI space, and specifically responsible AI. There's this notion that future conflict is going to machine speed, which is happening very quickly and quicker than humans can think. We're really focused on ensuring our ethics are built into those decisions, which is a very massive problem. We're working on a project with DARPA on this, and one with the CDAO. And so this is one of the spaces that we're emerging as leaders. We have a very nice offering in terms of unmanned surface vessel. But in that space, we're really focused on the autonomy stack on the vessel. So it's less about the robot and more about the digits, so to speak.
Yeah, I was actually on your boat, not recently. So for those in the audience, if you have widgets you want to test on a boat, you can talk to Mike.
Yeah. And our view of it also by being here was there's a convergence happening in terms of all these emerging disruptive technologies, and we want to harness that convergence with all due respect to divergence, but we want to harness that convergence and build a new capability together. So in a couple of weeks, we're going to be demonstrating alongside Microsoft, NVIDIA, Anello, Illyria, Second Front. I know I forgot a few, but all of these really exciting companies coming together to create a new capability together. And that's enabled by our autonomous ocean core, which is an open architecture, which enables that. Mythos AI. So again, exciting, the full stack there, from very small startup to NVIDIA and Microsoft teamed on this project.
Impressive. Cooper, I'm going to come over to you. So Divergent 3D kind of told us what you're generally about. I mean, the journey over the last 10, 11 years now, I mean, can you talk to us about it, the lessons learned, and where we still need to go? I also wanted to say I was on your website, and what you portray yourself to be your website doesn't really represent that. So
I'll be interested to hear more about what you did gather from our website, but it's been a journey since 2014. I joined Kevin Zinger, our founder, in 2017. At that time, we were still about 15 people. We were primarily focused in automotive. Kevin has an amazing career, is an exceptional once-in-a-lifetime talent and creator, but I'll just give like a very, very quick synopsis of how he started Divergent, because I think it's relevant to your question. But so after a successful career in law, working for Rudy Giuliani, actually going back further than that, after being a Hall of Fame football player at Yale, and then a successful career as a prosecutor in the early 80s, working for Rudy Giuliani back when he was widely regarded as, he was nonpartisan, regarded as a very, very effective leader. And then moving from that into Goldman Sachs and worked directly for John Thornton, stood up their London office and their Hong Kong office, so really stood up their entire global operations in the late 80s. Left that and ran a record label, which brought him out to Southern California, and then a couple tech companies that made him quite a bit of capital in the 90s, which allowed him to fund his passion, which was automotive. He grew up hot rodding in the streets of Cleveland, so he started a car company called Coda Automotive, headquartered in Santa Monica. And the mission in the early 2000s was to build the first commercially available electric vehicle based on a lithium-ion, prismatic cell, large prismatic cell, which at that time, nobody was even talking about that cell chemistry. Which, of course, fast forward 20 years, and he was absolutely right. Maybe a little bit early, and it pointed to he walked away from that endeavor with two really key lessons. One of which was he ended up spending more money on the design-specific capex for the car, even though he developed a very, very successful powertrain. That the battery factory that he built in China at the time, we had a lot different trade relations with China. We were actually promoting offshoring manufacturing. So he built a 1 million square foot factory in China for this prismatic cell. It's still in production today. So he was very successful with the powertrain technology, but of course the Coda car, you don't see them on the road today. And the reason for that is because the amount of capex required to launch a new vehicle. And it's due to the homologation, the validation of the safety structure. And he did it as cheap as possible. He built the car in China. He reused old FAW tooling, similar to what Elon did with the Roadster, buying old Lotus tools. And yet, the fact remains, right? It was more money spent on the thing we've been doing the same way for 100 years, since Bud Steel and Ford Motor Company in the early, generally the same. Than he did in developing a new successful technology in the powertrain. And so he walked away from that. And the other lesson was that, if you really look at the life cycle analysis and the carbon emissions associated with the full life cycle analysis, we have more carbon emissions associated with the manufacturing than really measured off the tailpipe. But that's less relevant to the main point, which is that, he walked away from that endeavor wanting to build a truly adaptive production system. He knew automotive because that was his world for the last 10 years. He was very connected in that space. So from 2014 to 2019, it was just existential invention mode. Small teams, flat organizational structure, funding was readily available, and we just solved problems quickly and developed the core fundamentals of the tech. Then from 2019, we found some beachhead customers in auto and started to really, it was early. We were still brute forcing our way through every program, but we forced the innovation by getting in with Ferrari. It was low volume production programs at the time, SF90 Stradale, Aston Martin, Maserati, a couple programs that really forced us to use the system, not in an R&D environment, but for a real program. That catalyzed the development for the next 2 years, fast forwarded to 2022, where we were in series production in automotive. Neil and Lyndon Blue at General Atomics, close friends of Kevin, Neil and Kevin serve on the same board at Yale. They visited our factory in 2022, and then we went down, visited Poway down here, and they said, we need this. We absolutely need this capability in defense, and that opened up our eyes to the state of the defense industrial base, which I think we can all agree is in serious need of repair. And so now the conversation over the last 2 years, I don't know if you read that Bloomberg report, Strategic Edge, that is divergent. I mean, you read that page to page, and that describes very, very well what we do. So that's our journey and how we got here. I hope that answered the question.
That's very helpful. I think it's good to set the scene, the stage here for all of us to be able to draw from. I agree with you. The DoD loves to reinvent the wheel a lot, and then over specify. I guess you had a little bit of a reaction, Lexi. So maybe kind of share with us your viewpoints.
Sure. So my background is Skunkworks, which is one of the biggest DoD customers in the world. We pride ourselves in doing things really quickly and very expensively, is what I would put it. So like when people think about quick manufacturing, I think the first thing that really drives to mind is actually cost, right? One-off tooling for 10 airplanes, 100, completely understand, but it's just the cost of those airplanes is insurmountable to the point that it actually I think degrades the aviation industry. It's the F-22 was supposed to be the savior for us, but we only order like 200 airplanes, right? And that was like multi-billion-dollar program, which is the cost per airplane is so expensive. So like as we think about our business, which is really destined around commercial first, DoD second, we really think about high volume, and we're not afraid to tool up. So like spending money up front, I think is very important because it allows us to create a process that's actually going to be replicatable, and also like for a safety net for commercial aviation. We need to be able to produce 2 737s a day. That's kind of like where the company is destined for. So I love to hear Divergent's story, and you guys as well, is like the idea of how do you not tool up and how do you make things expensive? But I guess the question maybe from my perspective is how do you make it inexpensive?
Maybe before you get into that, let me draw some information from Tam over here. So Tam, you come in from a kind of a machine. Tell us about your system. I believe it's hybrid, and you're probably serving both commercial and defense. So maybe tell us a little bit more.
We actually do mostly defense today, mostly defense and space, about 10%. We do with commercial aerospace. But I share a lot of sentiment here that, definitely doing things for DoD, things are moving way too slow, right? And we do things a lot faster than that. And a lot of problem that we're facing is just waiting for the approval and procurement cycle and things like that. And that's where the challenge is coming from people like us. Like all the things that are going on right now with the industry changing, with casting, forging, and now they have to change because the lead time become, too crazy out there, like 50-something weeks to get something like that, right? And then they need to change to someone like Divergent Technologies. But then the time it takes for someone to approve that, it takes almost like a year or so for the same time of getting like casting and forging. So those are the things that kind of the things that we see on our end in terms of like procurement cycle that need to be changed in terms of DoD and things like that. But for us right now, we still in the subtractive manufacturing. There's a lot of still traditional manufacturing, nothing that crazy technology like Divergent's building. But the things that we're doing a lot more advanced is that we incorporate a lot more sophisticated robotic system that we're building ourselves, and all the AI technologies, GPU right now, that allow us to do all those things. So we incorporate all that to basically streamline the process, getting parts done faster in the machining process. And that's really what we're focusing on right now.
Cooper, you were about to react to Alexei here.
Yeah, no, I mean, as somebody who spent the last 10 years of his career building a system that is fundamentally, gets rid of the need for tooling, obviously an incendiary question, but yeah, I mean, the way you drive down cost of adaptive and advanced manufacturing technologies is, one, you have to look at the entire system. If you look at additive manufacturing over the last 30 years, all you see are point solutions in the ecosystem. You see machine manufacturers trying to build a Swiss Army knife with almost no direction. You see software companies focused on specific elements of the value chain. You don't see any companies outside of Divergent that have looked at the entire value chain, generating materials that are specifically designed for laser powder bed fusion. Whereas most of the DoD, most of the industry at large is still talking about Inco 625, Inco 718, ALSI 10MG. These are cast grade alloys that were designed for an entirely different manufacturing process, which has cooling rates 1,000,000 degrees different than laser powder bed fusion. So materials, machine design, we've been able to design a machine that is literally a fraction of the cost of what you can find on the market and producing anywhere between 15 to 30 times faster. So at the end of the day, structure can be normalized down to just cost per kilogram or cost per pound, right?
Cooper, I have to ask you, would you sit and fly your family on a 3D printed airplane?
Absolutely. I can prove that. I put Mike in a 3D printed supercar that goes 300 miles an hour.
It's very different.
I don't know that it is. I mean, we have been, all of our structures that we have deployed for Ferrari and for Aston Martin and for McLaren and Bugatti and a number of other OEMs are safety critical. These are suspension, braking systems. If they fail, the driver's life is at risk. There's a higher probability that if that component fails, it will result in a death than not. And we have deployed, I mean, we are putting our servicemen and women in airplanes with additively manufactured parts, critical parts in them. I have complete confidence. In fact, I would be more concerned with putting a cast part with our current industrial base than I would with one of my parts. Absolutely. I have so much data. I have data on every single layer of the build, the thermal history, the pictures of every single build plate. If there's a void, I'll know it's there. And we can actually run that void through a damage tolerance computation analysis that allows us to know exactly what that void's going to do over time as the part progresses through its life cycle. So I have way more confidence in advanced manufacturing capabilities than I do in some of the conventional manufacturing approaches, particularly in our existing defense industrial base. And I think 3D printing it's tough because it has a very turbulent history, right? We have had a lot of failed components in the past. I think that's more a function of this, ecosystem of point solutions, and there not being a really like an end-to-end system that's ever been designed in the past. And I also think that it's okay to fail. Like, look at SpaceX. We're on launch number 7 of Starship, and I'm not saying put a human life in that yet.
Well, SpaceX doesn't 3D print rockets, so
the Raptor engine has more 3D printed parts in it than almost any other part or any other system that I know of. And I would say that's one of the biggest wins and maybe enablers to that system.
Yeah, I think it's a challenge to get the industry there just because we don't design for it and we don't understand it yet enough. Maybe soon. Maybe you guys are prototyping kind of the whole value chain. I guess maybe from Saab's perspective, how are you guys coming in at it?
Well, I can't speak specifically from the aerospace industry. I'm not the expert in that space, but I can tell you, I've been up to Divergent. I would like to associate myself with your remarks about Kevin. I think he's an amazing human, and he's built something very, very special. And we are collaborating with them on a few projects, and we're we're very excited about the early returns. And we see the opportunity for 3D printing to accelerate, and especially for a guy like me in Scapa, you can almost have this studio effect where you're designing with a very small team and you have a back-end manufacturing capacity teaming with a Divergent to really imagine, create, iterate, and scale. This is actually what we call the Scapa Innovation Flywheel. It's like I said, our first step is to imagine. So we get a bunch of different people focused on a problem from very different angles. We have a very talented and diverse team, everybody from Ford Motor Company to NATO to Crowd AI and all these really different people. And it's been my experience when you get a bunch of different people focused on a problem from different angles, you get novel solutions to that problem. So that imagine phase is the first phase. And in that phase, I would say the whiteboard is the most important piece of technology that we have. Then we go from imagine to create, where you change the idea to an MVP, teamed with folks like Divergent and others. Then you iterate in the operational environment alongside the end users. Then you get the product to a scalable solution, and then you scale. That's what's really exciting about Scapa by Saab, because we can solve problems at scale because we've got this amazing company backing us.
I do have a question about the operational user part. I mean, Task Force 59 was great in that you did have an operational environment. How do we replicate that? I mean, I know that we're doing something, I guess, down in Florida.
Yeah.
I don't know if we're doing something in San Diego, but that access to users is really hard.
Yeah, it's funny, Ellen, because I was literally on a call this morning with some colleagues at NATO who are looking to replicate the Task Force 59 model at NATO to address some key issues in the region there in Europe. So I think the model is scalable. It's just a matter of applying resource to the model. And now that I'm on the industry side, I really want access to the end users because I want their problems and I want to help them solve their problems fast. Having served 26 years, I'm still very mission focused, and I know we're in a race and in danger of losing that. And so, from the industry side, I want to help as much as I can, but I need access to the problems.
And I guess you do have a naval career. I mean, how are you talking to Third Fleet? And like, how do they react? I mean, what are the barriers that we could work to reduce just for all of us here?
Well, actually, I saw Newt, I think he's on the next panel from DIU. That's a huge asset. Obviously, we speak often with the Disruptive Capabilities Office, which is another huge asset in this process. Yeah, I think the mechanisms are in place. They just need some additional resource to scale the solutions.
I'm going to go back to kind of your pointing at the talent here, and then Lexi, I'll draw you into this conversation. So you mentioned the defense industrial base isn't ready. I would say just the commercial industrial base isn't ready. Like after COVID, the commercial side, we went from an average experience level of 20 to 4 right now. And so all of that brain drain, it's hard for people, machinists who have 20 years experience and machinists who have 4 years experience is a huge difference, right? So how I guess when you were talking about all the data you're collecting, I think that got me. Are you using that data and interfacing with the DoD and kind of convincing them? How does that work?
Yeah, I mean, a term that and by the way, I just want to say I completely agree. I don't think we should be using the term defense industrial base. I think we should use the term America's industrial base, right? Like 20, 30 years ago, it wasn't different,
Fun fact here, I was doing some research on this. Business Week actually held a reindustrialization conference, guess the year, 1980.
Jeez, yeah. Yeah. Well, I mean, but the conversation is right. I mean, now we have reindustrialized in Michigan. That conference was amazing last year. That was first time they had held that and had an amazing turnout, very high profile. I think Doug Beck was there, director of the DIU. And so anyway, I think the conversation is right, and I agree with you that both are broken, and both, you know, the war in Ukraine and the pandemic put that on full display. But yeah, so a term that the DoD uses quite often is digital twin. And with a system like Divergent, and I'm not pretending that Divergent solves the entire solution for any vehicle. We're not going to integrate the avionics for you. You know, we're not going to fill the vehicle with propellant. There's a number of other things, but the structure still takes up, I mean, Alexei will probably know best, but on average, maybe 30% of the vehicle bill of material costs. So it's a big proponent. And because we have so much data throughout the process, I mean, our raw material inputs can essentially be simplified to powder and adhesive. Powder goes into the into the additive manufacturing equipment. These are aluminum, Inconel, nickel, titanium powders that are made specifically for the process. And with those, we get all of the data from the morphology, meaning how spherical the powder is, the particle size distribution. We have, you know, tens of parameters that we're measuring all of this, including chemistry. And that goes into the machine. And then during the sintering process, you're getting all of the data from laser power to thermal history to a, you know, number of other things that I won't mention. But you know, throughout the assembly process, then all of those parts get either bonded or welded together. And because robots are doing those processes, and they're not doing them with pre-programmed, like path plans, it is algorithmic. It's logic-based. So it identifies the part. It knows based on that part's geometry what its next movement has to be. And then it's capturing all of that data so that we have that full digital twin of that process. And the DoD is particularly interested in that because what you can do with more computing power and more time and AI is then during the life of that aircraft, you can then start to understand how much damage is incurred or predicted to be incurred using, you know, damage tolerance models, and actually identify, okay, you had a defect in the process. It's going to happen. That's manufacturing 101. What is that defect going to do over the life of the vehicle? Now we can use high performance computing to predict that. And I think the DoD, DARPA is definitely thinking about that.
So, like, what part does this apply to your system or not? I mean, because you said composites, right? And so there's additive, there's composites. And like, how do you?
Yeah, I mean, one of the interesting things is like the most expensive parts are cars for rich people. I apologize, and Department of Defense, right? So I can see how the business model starts to play. I'm sorry to be like, you know, kind of like at the anti, but you know, what's really interesting is that metallurgy is a really huge part of FAA certification. So what's really interesting, I've seen like maybe thousands of 3D printing companies, but nobody, actually your team has produced a metallurgy report this morning, which I saw in my inbox, but like a metallurgy report that was actually certified by the FAA. So when we actually talk about combining epoxy resins with powder, how does it actually translate to material properties that is actually repeatable? And to certify one of those processes is between $10 and $50 million. So when you look at young companies specifically that are trying to do innovation within the aviation and defense business, they pick really expensive cars and Department of Defense, right? Because nobody cares about that. But when you look at airplanes where we need literally the metallurgy report of where the ore was mined for the FAA, that's difficult. And so repeatability and succinctness, and also I'm going to pick on you guys a little bit because I just saw the metallurgy reports, but you only have 2 properties of materials. So how can we create, you know, vastness of that data and have somebody, a company who's actually willing to certify that?
You mind, Ellen? Yeah, I mean, a lot there, but I think I will pick on a couple of things. One is I do think, so commercial aircraft, fine. I understand if you look at aviation regulatory bodies, the way I see it is a ladder. And you have like small attritable munitions. There's still a regulatory body that governs that, you know, Sea Eagle office within the Air Force or 4P in Navy. And then as you move up the ladder, FAA is the top of the ladder. And they're going to have the highest, you know, the most stringent regulations. Understandably, you know, you have many, many more souls at risk during the life of those vehicles. But do you think that we are being the most efficient or as efficient as we can with those $15 to $20 million to qualify new materials? I mean, let me give you a couple data points. I test over 1,000 Tencel coupons for our aluminum a week. Every single week, I have over 1,000 Tencel coupons. And you say I only have a couple properties. I mean, I'm not sure what report we shared, but I have everything from fracture toughness, over 100 samples in every print orientation. I have, like I said, thousands of Tencel coupons a week, fatigue, rotating beam fatigue, and axial. I mean, I've got more data than, so we're partnered with the Air Force. Again, we have picked our ladder based, of course, on growing through the volumes of the vehicles that make sense. So lower volume, the price point of hypercars and supercars are higher than the price point of a Toyota. But to that, I would argue commercial aircraft, I mean, the targets I've seen are still, what, on average of like $400 or $500 a pound. Is that right? We're well in exceedance of that. We would make healthy margin for selling structure into that. What we wouldn't do is make any money going through a $20 million qualification process. That has to change. I think we have enough capability in computing power and computational material models for that to change. I think it'll happen through the DoD first. I think it won't happen. But if we start practicing like we'll play or training like we'll fight, we will not qualify materials in the way we qualify today. It can't take 9 months and $15 million to enter a new material into
Yeah, we
our
didn't do it
industrial
during the
base.
Freedom Forge period time, right? Like
Yeah.
all the rules went out the window.
Yeah. But so I would say we need to qualify materials faster. We need to have a little less, I wouldn't say a little less regulation, but we have smarter regulations that are more representative of current state of technology and the problem statement with our industrial base. And I would say that we have already achieved a price per kilogram that's relevant for commercial aircraft, but we haven't achieved a political landscape that allows for qualification in a timely manner. And so we're going to work our way up that ladder because that makes the most sense. I think a number of other companies. So we'll start with munitions and we'll graduate into more exquisite aircraft. But you can see other companies like Boeing moving directly into commercial aircraft with additive applications. I don't think the problem is technical. I think the problem is political.
Well, we have about 10 minutes left, so I do want to open it up to the audience here. Yeah, please. Let me repeat the question just for the audience or the virtual audience. So basically the question about sustainability and how does the customers as well as or investors figure into that and think about SAF or other sustainability issues?
I think there's a huge play in SAF. So I think a lot of our customers will leave it into more and sustainability more than what we do. We do believe that Boeing has kind of faltered on that, and Airbus as well, over the last 20 to, well, actually 50 years if you actually look at it. But we are big believers in it, but it can't be a step change in technology. It has to be kind of like the running joke in our industry is never put a brand new engine on a brand new airplane. So we are blended wing body. We're very cutting edge traditional engines to start out with. And I think our customers appreciate that. Hence the $14 billion order from a tier one airline, I guess. But, we do believe that we are the enabling technology or platform to take the next step. But sustainability and defense don't go together. And unfortunately, we do talk about defense because that's part of our business. Very different, I would say.
Anybody else? Okay, to repeat the question, and I'll summarize, how will the new administration impact your businesses? I guess maybe, Michael, I'll start with you.
I would say that's a fair assessment. And if you look at the testimony of Pete Hegseth, he was leaning into this. I would say we're really optimistic about the future, and not only in terms of this injection of new tech and non-traditionals, but also this notion of raising the bar in terms of investment across NATO he's talked about 5%. I think that's necessary in order to meet the challenge of the times. So I'm very, very optimistic. We're apolitical in this regard, but very, very excited about the future.
Yeah, great question. Share the optimism, absolutely. I think what we need to do in order to right now, I think it takes on average 11 years to build a new capability in our Department of Defense. 11 years, and if you compare that to the need being demonstrated in Ukraine,
if we build it at all, because the Navy really has not built anything over the past 20 years.
That average has probably got some pretty big error bars. Well, on one side, but you compare that with the need in Ukraine, where there's 3-month development cycles. Ukraine comes up with a new drone technology that's met in response 3 months later to Russia, so on and so forth. Where does 11-year development cycles fit in? I think what's going to happen, what I'm hopeful is going to happen, is we're going to see a lot more public-private partnerships. We're going to see a lot more private equity and venture capital money going into defense technology, new innovation technology. And what that's going to help do is rebuild, re-democratize our defense industry. And you're going to see a lot more non-traditionals win contracts because they'll be able to be funded through the valley of death, right? So they won't be completely dependent on DoD funding. There'll be a lot more certainty as a venture capitalist or in private equity in funding some of these new capabilities. So I think already, even just the conversation has helped. Even if there's no policy or no legislation, just the conversation and the narrative is going to help us inject more money into new capabilities and help bring more competition into the landscape.
Actually, I'll lean into that. I was recently at the Bank of America Aerospace and Defense Conference, which Ron Epstein runs, right? And I'm thinking, and then we had like Shield AI and, four different, like, about to IPO to defense tech startups there. I'm like, I wonder why they're at Bank of America, but, that's what they're there for.
I'm going to correct something. I think there should and needs to be policy and legislation. I don't think it's enough. So when I said already it's helping, I think that's probably, I want to rescind that. Take that away. I think, we need to move a lot faster.
Tam, how does the administration or the tech-first administration help you?
I definitely share the same optimism as well. On my end, I think I touched a little bit earlier about the procurement process. And to me, I think right now the defense traditionally taking too long. It's just that layers of bureaucracy and the process there, right? So traditionally, it's been like slow and steady and making sure things are being built in the right place and in the right way. But I mean, right now, I think for many, many years now, decades now, that we proved that's taking way too long for things to be iterate fast and learn fast. And I hope with these new individuals from the tech side coming in, bringing somewhat that the mix-up culture more like, and tech has been like learn fast, right? Iterate fast. And I'm hoping that they would mix some of that in and take some more rest in certain new things like new processes, new technologies, and help the country move faster. That's on the technology side, but in terms of procurement process as well, like people have made a big movement in industries such as like SpaceX, making a big change in NASA, the way they're doing things right now, right? A lot of space program now started to go private because of that. And now with the defense side, also started to go a little bit more private too with Anduril and some other companies. So I'm hoping that that's going to be the case toward that trend in the future. That way we can help truly build out new technologies and applications faster in the defense work. So that's really where I'm hoping for in this new administration. So
I wonder if the DOGE plays into that. I was hearing a statistic that the DoD's overhead has gone from 10% to 35%. So that's a lot more people. So a lot more people always looking for jobs, something to do, something to say no to. So, Alexi, how about you?
I mean, I guess I'm like the odd man out, but I feel nothing's changed. Crazy to say.
Change.
Nothing is going to change. The military industrial complex is so big, right? So if you look at like the big contracts, like the we're really interested in and we're bidding on, it's like NGAS, next generation strategic airlift, next generation strategic tankers. Those are like 2035, 2040 contracts. And you would think with the new administration, like something would have moved to the left. Nothing has moved. So I guess like I feel like we're still.
Well, they haven't been inaugurated yet, so I mean.
Well. I would love to have this panel in a year from now, and I'm eating my words. But right now,
we'll give them their scorecard.
There you go. But right now, I think it's such a big machine. Nothing's going to change, in my opinion.
Dumber, I would rather. So, anyway, I guess how many more minutes do we have? Less than a minute. Okay. Well, one last question, a real flash question. What's the secret sauce to penetrating the bureaucracy?
Advisors.
Right? Like you got Nate Diller, you probably have a bunch of advisors. Michael comes with 26 years of frustration.
That's a great question. It's something I think a lot about, having just gone to the private sector. And this is a lame answer, but I haven't figured it out yet. It was, it's much harder on this side. I was the customer before. I worked with 23 different customers, industry partners when I was at Task Force 59. And on this side, it's very, very challenging for all the reasons you mentioned. I think at the end of the day, if you put the mission above everything else, you hire really good and smart people that are mission focused. And that's what we're doing at Scapa and Saab, and I hope that's a winning solution. But I'm not sure. We've won a few contracts, so we're off to a good start. But that's our approach.
It's a very interesting question. I had a unique privilege of working in automotive and establishing relationships with many major automotive OEMs, and the decision-making criteria was a lot simpler in those organizations. You kind of infiltrate the C-suite, inject the interest and demand and value there. It funnels down. You find a champion at the chief engineer level, and you're going to be on a program, within the next, probably 6 months, because it's not a bureaucracy, right? Not in the same way that a true bureaucracy like the U.S. government, I don't mean that in a bad way, operates. You can have somebody at the top say, we're going to do this. It happened at Aston Martin, our first contract. Tobias Moore, as the CEO of Aston at the time, was saying, we're going to put Divergent on the V12 Vantage. 6 months later, we were on the V12 Vantage. There's nobody except for maybe, Secretary of Defense that can do that. There's a lot of people that can say no. Everybody can say no. Maybe only one person can say yes, maybe, which is how the government was designed to work. I believe in separation of power, and I believe in all of that. But I think to Ellen's point, I
wanted to add something.
Yeah, no. You do need help. There's no way. We tried to brute force it for 12 months, and we did. We had some success, but friends like Mike Pursuer introducing us to now, Nate Diller, who leads our defense strategy team. Without individuals like that can guide you through that bureaucracy, I'm not sure there's a chance that you can figure it all out yourself.
I think one of the possible solutions, and if we could get to a space where the problem holders, those at the edge, those closest to the problem, also had more say in terms of where the resources applied, that will accelerate innovation and in this case, divergence, where you have all these people at the edge very close to the problem, innovating and accelerating new capability to solve their respective problems. I think that's part of the solution, but we'll see if that plays out.
Yeah. Well, let's give us, the panelists, a round of applause. We really appreciate this conversation. To be continued. So 1 year from now.